Hello everyone, my name is Greg and I dev stuff. Welcome everyone to episode 2 of the tactics game in Unity. Today we want to introduce clicking things on the map and placing a map objects. Let's rescale our terrain a little. Select the main camera and let's create another new component called grid control. Inside, immediately create the serialized target grid variable. This way we can reference the grid we will be interacting from the scene. So what we're going to do is to click on the screen with a mouse and send a ray towards the terrain object. When ray intersects with the terrain, we will get the position of the point of intersection. And using this position we will determine the position on the grid, based on the size of each node. So let's make a serialized field for terrain layer mask. So when you will be shooting the ray, you can ignore every other collider except the terrain. Okay, now in the update, if you press left mouse button, we want to shoot the ray from the screen towards the terrain, from the point of the mouse pointer. To do this, create a new ray, which will be shot from the main camera using screen point to ray. Then call physics ray cast, which will cast the ray we have created. We need to store the raycast hit information into the variable. Then we want to use layer mask. And raycast wants to have a length of the ray in that case. Just tell it to have a float max value length. If we put all of this into the if statement, that means everything inside those brackets will be executed only if you hit something. In our case, only if you hit terrain. So inside those brackets we want to pass our world position from the hit to the target grid and get the converted world position into the grid position. So inside we want to calculate the position on the grid. Calculate the position relative to the grid. To do this, offset the world position by the transform position. Now calculate position on grid by dividing the world position by the cell size. Disclaimer: I am aware that this offsetting of the grid is not efficient and will give a performance hit. We will optimize the grid in the next episode, and I will give you explanation when you want to keep all of those calculations in, instead of removing them for optimization. Put the position on the grid into debug. Let's set up fields, set the terrain, and set the layer. Move the camera for better view. Launch the game and let's see. Good. As you can see, it works. It might look a little weird because the camera makes it a little distorted. This episode is brought to you by generous support of people on Patreon and members on YouTube. If you want to join them, link to my Patreon in the description. And join button available right now on YouTube. Now let's talk about placing object on our grid. You see, one of the important things you want to do is to ensure the ability to prototype and test your game as fast as possible. That includes the ability to just pick a character and plop him into the scene, and he will work immediately. So what we are going to create now is grid object, an object which is present on the grid. Before, let's clean our scene a little by attaching obstacles to the terrain and attaching terrain to the grid. Now let's create a capsule to represent the character on the scene, who will be our grid object. Actually, let's place the capsule into an empty object container, then rename the container into character. Create another new component called character to the character object. Open the character script and add a new serialized variable called name. Actually make it public. Good. Now create another new script grid object. Open newly created script. Created script will be responsible for character stats and attributes. Meanwhile, grid object will be responsible for placing our character onto the grid and interacting with this grid. So think about this like this. Character is your RPG system. It's HPs, it's names, it's what kind of weapon this character is holding. Meanwhile, the grid object is how this character will move around, pathfinding, placing the character in the grid, interacting with this grid. That's the point. Inside this script, on start, create and call a new script called init. In this method, get the position on grid for this object by passing the position of the object. Then using this position, place the object on the grid. Create a new method in the grid to place the object. Pass position and the object itself using this keyword. Inside the place object, simply place the object into a node. For this, we will have to create a new public variable in the node. Assign grid to the field. Where we test the field, make a debug message which will post the name of the object in the grid. To do this, create a new method called getPlaceObject and pass the grid position. Return the grid object out of the grid using this grid position. Then check if the grid object which we return out of the grid is null. Then post a message that this position is empty. Otherwise, post the name of the character. Doing something like this is not very efficient, so we will remove this soon. It's just for testing purposes. If we launch the game right now, it will throw an error. This is because our nodes are not initialized yet. Add initialization of nodes in the create grid. And now you have witnessed what is called an out-of-order error. You see, we have initialized the nodes, but our object still throws the same error. This is happening because the object is being placed into the grid at the start. Meanwhile, the grid is being generated at the start too. That means there is a chance that the object will be placed before the grid is initialized. To avoid this from happening, let's initialize a grid on the awake, which always fires up before the start. This will fix the error. Now let's try to place the object inside the grid. This will throw an index out of range exception. This exception or error, if you want, is caused by trying to access the array outside its boundaries. As you can see, our character stands way outside the boundaries of the grid. What we need to do is, inside the placeObject method, call a boundaries check. So create a new method called checkBoundary. Inside we want to do a check for boundaries, so check if the position on grid passed as a parameter is inside the length and width of the grid. If it is inside, return true, otherwise return false. Use check boundaries to limit the placement of the object. If check boundaries return true, only then place an object. Good. Let's post a message if you are trying to place an object outside the boundaries. Now if you keep clicking around outside the terrain, everything is okay, because we are not registering a hit. But inside the terrain, the Unity will throw an error, similar to the one we had with placeObject. Well, it can be fixed exactly the same way. In the getPlaceObject, call checkBoundary, and in case we are inside the boundaries, return object, otherwise return null. So every time you interact with the grid, you want to check boundaries in case you're trying to interact with the grid outside its boundaries. Good, this is it for this episode. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. Special thank you to Andrew V. Long for his generous support. With best regards, see you in the next episode.